We now have arithmetic sequences, or some people call them arithmetic sequences. It's your preference. I use arithmetic. So an arithmetic sequence is a sequence in which each term differs by the same value. And the terms that we have in our equation are un, which is the nth term, which we saw in the last video, n, which is the term number, and d is the common difference. So in an arithmetic sequence, the difference is the same between each number. So it could be 2, 4, 6, 8, 10. The difference between each number in that situation is 2. And our formula for an arithmetic sequence is un equals u1 plus, in brackets, n minus 1 multiplied by d. So we have a few examples to get through. So the first one, consider the sequence 3, 9, 15, 21, 27. Show that the sequence is arithmetic. Then we want to find the formula, find the 100th term, and then work out if these two numbers are a member of the sequence. So first of all, show that it's an arithmetic sequence. So to do that, we want to show that the difference between each number is the same. So that 9 minus 3 is 6. Now we want to show that 15 minus 9 also equals 6, and 21 minus 15 equals 6. 27 minus 21 equals 6. So showing that the difference between each number is 6, therefore it's an arithmetic sequence. For B, find the formula for the general term. So remember, our general term is un equals u1 plus, in brackets, n minus 1 multiplied by d. And now we just sub values in. So un is what we'll be trying to find, so that stays. Now u1, we just look at the sequence and find the first term. So u1 is the first term. And in this question, it is 3 plus n minus 1 stays because n is our variable. Now d is our difference, which we now know is 6. And then from here you can expand and simplify. So we'd have 3 plus 6n minus 6, which equals 6n minus 3. So that is our general term. You don't need to simplify. You could leave it at that second line there with the value substituted in. It's your choice. C, we want to find the 100th term. So for part C, we want to find the 100th term. So we're just going to sub 100 into our formula. So we want to find u of 100, which will equal 6 times 100 minus 3, which would equal 597. The other way, if you subbed it into that second line of working, you'd have u100 equals 3 plus 100 minus 1 multiplied by 6, and put that in your calculator and you get 597. So you can do it either way. Now, D, we want to know, are these two numbers, 489 and 1592, a part of the sequence? So to work that out, we want to sub 489 as our term, and then rearrange, and if we get a nice number for n at the answer, so basically not a decimal, then it's a part of the sequence. If we end up with a decimal value for n, then it's not a part of the sequence. So for 489, we'll have 489 equals 6n minus 3, and we just rearrange this. So we plus 3 to the other side, so we'll have 492 equals 6n. Divide the 6 to the other side, and we'll end up with 82 equals n. So 489 is a member of the sequence. It's the 82nd term. So I'll just write there, so therefore the 82nd term is 489. And then we just do the same for the second number, which is 1592. So we've got 1592 equals 6n minus 3. Rearrange that, so 1595 will equal 6n. Divide the 6, which will give us 265.833 recurring, which equals n. Therefore, it is not a member of the sequence because we can't have a decimal term number. Example 2. Find k, given that k plus 5, negative 1, and 2k minus 1 are consecutive terms of an arithmetic sequence. And we want to find k. So the way we do this is we know that the difference between these in an arithmetic sequence must be the same. So minus 1 minus k plus 5 equals the difference. And then we also know that 2k minus 1 minus minus 1 also equals the difference. And we can equate these to each other and find out what k is. So we'll have minus 1 minus k plus 5 must equal 2k minus 1 minus minus 1. Now we've just simplified this. So we'll have minus 1 minus k minus 5 equals 2k minus 1 plus 1. And we'll have minus k minus 6 equals 2k minus 6 equals 3k, and therefore k equals minus 2. And our final example, find the general term un for an arithmetic sequence given that u3 equals 4 and u7 equals negative 24. So this time we're not given u1, we're not given d, but we're just given two of the terms, so we have to use that, and we'll end up using simultaneous equations. So if we know that u3 equals 4, we can put 4 into a u3 equation. So remember, u3 will also equal u1 plus 3 minus 1 multiplied by d. And if u3 equals 4, we know that this will be 4 equals u1 plus 2d. Then we can do the same for u7. So that u7 equals negative 24, so u7 would equal u1 plus 7 minus 1d. And that negative 24 would equal u1 plus 6d. Now we have that, we've got two equations, we can solve them simultaneously. So you choose whichever simultaneous equation you would like. I'm going to, let's do by elimination for some fun. So I'm going to have u1 plus 2d equals 4, u1 plus 6d equals negative 24. I'm going to minus these two equations from each other. So the u1s will cancel, we'll have minus 4d will equal 28, so d must equal negative 7. So now I've got negative 7, I can work out what u1 is. So I'm just going to sub that into either of the equations. I'll do it into the first one because it's nicer numbers. So but u1 plus 2 times negative 7 equals 4. So u1 minus 14 equals 4, so u1 must equal 18. Now there is a much quicker way to find u1 and d, but I often forget to do it this way because I just prefer using simultaneous equations. But what you can do to also find u1 and d is to find d first. What you can actually do is you can actually do the u7 minus u3, and then divide that by the 7 minus 3, so the actual term numbers. So you get negative 24 minus 4 over 4, which will be negative 28 over 4, which equals negative 7. So that's your difference. And then from there you can go work out what u1 is. So either way works, your choice as to which you would prefer. And then from there we can just write it into our general form. So we'd have un equals 18 plus n minus 1 multiplied by negative 7. And then you can expand and simplify that if you wish.